Hello students, we'll be reviewing our question 2 of our Chemistry Sec 4 practice paper. If you have not watched question 1 review yet, you can refer to the previous video if you're curious. But if not, let's get started with the second question. So cold water was added to phosphorus pentachloride to produce hydrogen chloride as shown by this reaction here. So it is known that hydrogen chloride is a corrosive gas to breathe in. As we all might know, hydrogen chloride, which is HCl gas, actually dissolves in water to form hydrochloric acid. And for which all of us know that this is also corrosive lah. So how this gas is corrosive is because actually if you breathe it in, because your inner walls of your respiratory system all has a layer of moisture, so this hydrogen chloride gas which is very soluble will actually dissolve in this moisture and form hydrochloric acid, which would damage your tissue. So it's very dangerous. So we must identify two precautions so that we minimize breathing in hydrogen chloride gas. So how can we do this? First of all, we can make sure we carry out the experiment in a well ventilated area. And second, we can wear a gas mask to reduce the amount of HCl inhaled if there is. So second part, we have Donaldson, which had claimed that the following reaction, which is the reaction here, is a redox reaction. So redox reaction involves change in oxidation states from reactant to product. So do you agree with him? Explain using the idea of oxidation states. So we must scrutinize this equation here. So we commonly know that Cl is -1 oxidation state, and since there's 5, so it will be -1 times 5, which is -5. And we know that this is a neutral molecule. So if it's a neutral molecule, the P must balance out the -5, and it can balance out the -5 if it's +5. So for water, it's very straightforward because it's very common. So it will be +1 times 2, and this will naturally be -2 to balance out the charge. So now is the crucial part we need to look at, which is the product. So we realize that in POCl3, first of all, Cl is likely to be -1 as we have encountered. So this will be -1 times 3, and oxygen is likely -2, other than in H2O2 where oxygen is -1, but this is not H2O2, so it's likely -2. So if it's -2, then if we sum all of this out, it will be -5. So P would likely be +5. So we realize one thing: P, the oxidation state of P never changed. So is this really a redox reaction? Let's finish balancing, finding all the oxidation states first before we come to a conclusion. But H is +1 here, as we all know, and Cl is -1. So we realize that for Cl also, which is -1 at first, after the reaction, the Cl is still -1, so there's no change in oxidation state. And for oxygen, -2, -2, no change in oxidation state. And same for H, which is +1 before and +1 after, there's still no change in oxidation state. So we can conclude that I disagree with him. And all of the stuff that I had said just now, you can write it down here. But the main focus is the main idea here is about there's no change in oxidation state of these individual atoms before the reaction and after, basically your reactants and your products. So this is therefore not a redox reaction where reduction and oxidation takes place. So now for part 3, which is a chemical bonding question, it's quite easy. So it says that HCl has a lower melting point than magnesium metal. So explain using the idea of structure and bonding for this case. So For HCl, HCl is a simple covalent molecule with a simple covalent structure. So between HCl, and HCl, what is there? What is this force? Is weak intermolecular forces of attraction. So since it's weak, right? So you don't need as much energy to overcome these forces, to break them apart, break them apart, break them apart, and break them apart. So therefore, the amount of energy needed is very low, so your melting point will be also very low, because only a little bit of energy is needed to overcome these weak intermolecular forces of attraction between these HCl molecules. Take note, these forces are between HCl molecules and not these forces of itself, because these bonds are actually covalent bonds, so it's not contributing to the the melting point, because if you were to break these bonds, it becomes a whole new compound. So now let's look at magnesium metal, which has a higher melting point. So why does magnesium metal have a higher melting point? We know that magnesium metal is a giant metallic lattice structure, and it has C of delocalized electrons. So if it has C of delocalized electrons, there's also Mg2 plus cations. So between the Mg2 plus cations and the C of the localized electrons, there's strong electrostatic forces of attraction. So these strong electrostatic forces of attraction require large amounts of energy to overcome, and that is why its melting point is high, because a lot of energy is needed at a high temperature to overcome these bonds for magnesium metal to become Mg gas. Okay, so this is Mg liquid, because this is melting point. So that is why HCl has a lower melting point than magnesium metal, and you need to encapsulate all your ideas in your answer here. Thank you, and see you on the next